So the cotangent, when you graph it, this is the parent function. So let's graph it really quickly. We could use our unit circle to help us with a little bit of it. So, and our left-hand rule. So what's the left-hand rule? Tangent of 0 is going to be 0. And then the tangent at pi over 2, if you look at it, it's going to be an asymptote. So if I know those two, I know a lot of stuff. So if I know this one here, I know this one. So that's negative pi. That's also pi. And then that is 2 pi and negative 2 pi. I know it's going to be 0. And then if I know 90 or pi over 2, I also know 3 pi over 2. So that's an asymptote. This is an asymptote. And this is an asymptote. So that's what you look at by looking at the unit circle. And then that's not enough information. So then I need to know, I could do all students take CAT again on there. So all students take CAT for tangent. I know this has to be above, which makes sense because what happens is that I am going to do the 45 degrees because I know tangent of 45 degrees is 1. So that is actually your pi over 4. So the pi over 4 is going to be 1. I know it's above because everything's positive. And then this one here, if we go over there, all students take CAT. That's a negative pi over 4 there. And so that's going to be at negative 1. So if we look at it, this here is what that is going to be, because in the fourth quadrant or the negative 1 quadrant right here, this is going to be a negative 1 because tangent's negative there. And then it just keeps repeating and repeating again and again. So what do we know about this parent function? This parent function has a period. That means that it repeats every pi. This is half a pi. So this here is half a pi and this here is half a pi. So it has, unlike sine and cosine, a period of pi. So when we're graphing this one over here, now that we have to look at this, there is an A, there's a B, but there is no C and D. So there is no phase shift and no vertical shift. We're not shifting it left, we're not shifting it right or up and down. But this A for tangent, anything that's unbounded is not going to have an amplitude. But there is still a horizontal stretch and shrink. So if, there is none here, but it's still going to stretch to 4 and negative 4. So there has to be, it's not going to stay at 1 and 1. So I really don't like the fact that they say that there is no amplitude. But by definition, there isn't. But here there is going to be a vertical stretch or a shrink. In this case here, it's going to be a stretch because we're multiplying all the y values by 4. Now this one here is your B. That's going to be a horizontal stretch or shrink. Inside, it's always the opposite. It's supposed to shrink it by 1/3, but what it actually does is it stretches it by 3. So we're what is it's being stretched? And it's going to be the period. So we know that the period of the parent function that we found out earlier is pi. So that means that I am going to multiply it by its reciprocal. And so the new period is going to be 3 pi. So that means that I am going to take the 3 pi and I am going to split it up into 4 equal parts. If I put it between 0 and pi, it's still going to be 4 equal parts, and then I could do the negative on the other side. So I am going to split this into 4 equal parts. In this case here, this one here is going to end up being 3 pi. So I know that I'm going to multiply this by 4 or by 1/4 or divided by 4 is the same thing. So the first tick mark is going to be 3 pi over 4. So that's going to be 3 pi over 4. And no, I'm not doing the 2 pi. This is just the length from here to here. So I'm only doing from 0 to pi is the same as 0 to 3 pi because I stretched the pi to 3 pi. So just so you know that this is not equivalent, the 3 pi is not equivalent to the 2 pi. It's equivalent to this pi right there. Okay, so then that's 3 pi over 4. And so we could count, the next one's going to be 2, 3 pi over 4. And then the next one's going to be 3 of them, 3 pi's over 4. And then the next one's going to be 4, 3 pi's over 4. So you're just counting. This one here is going to be 1 of them. And then this one here is going to be 2. But this one's going to reduce to 3 pi over 2. This one here is just going to be 9 pi over 4, and this one here is going to reduce to just 3 pi, which is what we should have at the end. So this is 3 pi over 4. This one here is 3 pi over 2. And this one here is 9 pi over 4, and then 3 pi. And then I could do the same thing on the other side. They're going to be equivalent, except for they're going to be negative. And so that's what I've done. I just stretched it because this is 3 pi, so 1 pi is around over here. So the next thing we want to do is that we're stretching the y value. So instead of going up to 1, it is now going to go up to 4. So I'm just going to put 4 over here and negative 4 down here. So the asymptotes, now everything's going to be the same. The pi over 4 is this one. If we look, the pi over 2 is equivalent to this. So this one, if we were to write it, this is your pi over 4. This here is your pi over 2. And then this one here is your 3 pi over 4. And then this one here is your, I'm sorry, I wrote down 2 pi when I'm just supposed to write down pi. But we just stretched it to fit these numbers. So these are the equivalent values on there. So the asymptote is going to happen at pi over 2. So that's where you're going to have an asymptote. I'm just going to do it in a different color because that's just too much red. So this here is going to be your asymptote. And so then this one here is going to be your asymptote. And then this here is equivalent to your pi's over 4s. This one's supposed to be at 1, but since we're stretching it, it's going to go to 4. And this one's supposed to go down to negative 1. So this here is what the tangent looks like. So if you notice, this 3 pi is equivalent to this pi. So you would do the same thing. And then this one here would be at 4. And so we only have this part on there. So we only graphed it up to this part and then this part right there. If we wanted 2 full cycles, you could start doing, this is 1 cycle, and then you could do the other part over here where it's going to be at 4, at 0, and it's going to look like that. So you got the top half here, the bottom half there, and there is your tangent. And that has been stretched vertically and stretched horizontally. So the cotangent parent function, we're going to graph it the same way that we did the tangent. And so we have our unit circle and we have our left hand. So what is the cotangent of 0? So the cotangent of 0 is an asymptote. So we put an asymptote at 0. So that's 0, and we know that happens on the other side as well. So it's going to happen at pi, there's another asymptote, and at negative pi, there's another asymptote. Then we do the cotangent of 90. Cotangent of 90, oops, I put the erase button there. Sorry. The cotangent of 90 is going to be 0. And so it's also here at 270. Or 3 pi over 2, and then 2 pi. And so it's the same thing that would go around there. So we know that that's what it looks like. We know that there's asymptotes all over the place, wherever 0 and 2 pi on there. Okay, so now just like tangent, we have to do something in the middle of these because there's asymptotes and then 0. So we know that the tangent or the cotangent of pi over 4 is still 1. This is still the all students take CAT there. So this one here is going to be pi over 4. We know it's going to be a positive 1. And then students here, so there's going to be negative 1. So we know that there's going to be a negative 1 there and a positive 1 there. And so we looks like this. So the cotangent looks this way, and it just keeps being repeated. Notice how it does 1 period within pi, and it does the same thing again. But it's at pi over 4, at 3 pi over 4, and at pi over 2, and at pi. So it's split up into 4 equal parts. So the period is still pi. So when we're going to graph this one over here, we see that we have a d because that's being added to our function on the outside, not being multiplied. So we have a d, so that's a vertical shift. We're shifting up by 1/2. There is no amplitude, So there is none there. There's usually none anyway because this one here is unbounded. The period here, that's going to be defined by your b. And so the period of it is going to be pi if there was no shifting on there. But there is a b, I'm sorry, if there was no stretching or shrinking. There is a b, so therefore it's going to do the opposite. It's 1/2. It's supposed to shrink it, but now we're going to multiply it by 2. So the period is going to be 2 pi. So we're stretching it. So whatever happens within 1 pi, now it's going to happen within 2 pi. So we're going to take this period and we're going to split it into 4 equal parts. So here's the 2 pi. And so divided by 4, well, we always divide, those are the quadrantal angles when we divide 2 pi into it. So this is going to be pi over 2. This one's going to be pi. This is going to be 3 pi over 2. So whatever happens here is what's going to happen here because everything's going to be stretched. So this pi over 2 is actually this pi over 4. This pi is the pi over 2, so on and so forth. So we know that at pi, there's an asymptote. So therefore, we're going to have that there's an asymptote at 2 pi, and it's still an asymptote at 0. And then we know that at pi over 2 is 0, so it's going to be pi there. So we know it's going to be there. At pi over 2 is the pi over 4. That's where it's going to be 1. This one here is going to be shifted up, and I'll show you how to do that in just a sec. So if we were to look at it, it's going to be at, then we could say that this one here is 1. It's going to be looking like this. And then let's say this here is 1. So it's going to be looking like that. So if we notice, it's been stretched out, but it's also been shifted up. So the easiest way is I'm just going to show you how it was stretching and how everything's going to be that. But everything's been shifted up by 1/2. So that means that wherever this is now, this is not going to be at 1. It's going to be at 1.5. So if this is 1, this here would be 1.5 because this part right over here is going to be 2. So everything's shifted up by 1/2. So therefore, this is 1/2. So the new x-axis, if we look at it, is going to happen at 1/2. So that's where it's actually going to start the new x-axis. Everything has been shifted up. So it's much easier to see that the x-axis has been shifted up. And so that one there is going to be at pi over 2. And so therefore, when you graph it, it's going to be at 1. And then this is your new 0. And then this has been shifted up by 1/2. And so this here is your cotangent graph. So it's at 1.5 because it's been shifted. This here is your new x-axis. Bad, that's very not straight. Sorry about that. That's your new x-axis, so it's going to be crossing there. And so then you could do the same thing on the other side, and then you'll be graphing it over 2 periods. So if we look, to, and so we have the asymptotes. Sorry, that's in the wrong place. So that's going to be a 2 pi. We're going to do this and 1.5 right there and right there. So it's going to look like that. And so that's that twice, 2 periods, and that's the cotangent shifted up. Very good.